Hello friends, welcome all to the fourth video in the series of data structures and algorithms practice daily. In this fourth video, we are going to discuss a question of deleting a node in linked list. This question is very interesting and this is going to teach you a lot of things. It may seem similar at first, but when you try and do it, it teaches you a lot of things. Before jumping on to this, let me just explain to you about the group which I am talking about. So basically, I have created a group which is dedicated to mastery of data structures and algorithms, and daily one question is posted and next day the solution is discussed. So basically you have around 24 hours to try the question by yourself. If you're facing any doubts, you can message me and the solution will be discussed the next day. Okay, and why is important to master data structures and algorithms? The reason is great companies and tech giants like Amazon, Microsoft focus heavily on problem solving skills, oops concept, and data structures and algorithms. By asking questions on data structures and algorithms and conducting coding rounds on the same, they're able to gauge whether you are a problem solver, whether you can think for yourself, right? And that's why they rely heavily on this, and they believe if you are good at these, you are a fast learner, you have a sharp brain, and you will be able to learn all the technologies and problems you will be thrown on during the job. Okay, so the group is dedicated to that. You will be seeing a link somewhere, just click on that and you will be able to join it. Learnwithakshaya.com DSA daily should be the link. Okay, so now let's jump onto the question and try and solve it. If you have not solved this question before and you're watching the video for the first time, I would recommend you pause the video right now and try to do the question by yourself. Okay, so let's try and understand the question. Delete node in a linked list. Okay, you must already be knowing what a linked list is. Linked list is basically a list where each element is linked to one another, right? I gave an example in the previous video also. Linked list is like traveling through in a building by going on the stairs. So if you want to reach fifth floor and you are on the first floor, you have to first go to the second floor, you have to then go to the third floor, and so on, fourth floor, and then fifth floor, right? There are other data structures like arrays where even if you are on first floor, you can go directly to the fifth floor with the help of a lift. You can directly jump over there. Okay, because of the constant in which you are able to traverse through a linked list or an array, there are different properties which they have, which make the problems very interesting. Okay, linked list can take its own class, so I won't go in details on much over that. So we will probably have another class on that. Let's try and discuss the problem which is at hand. Delete node in a linked list. Let's read the question definition. Description: write a function to delete a node except the tail in a singly linked list given access to that node. Okay, so there are very two important things to note over here, which is accept the tail. I will later give you a reason why the question has said accept the tail, because if the condition of tail wasn't an exception, you won't be able to complete the question. Okay, and it is also very important to note that it's a singly linked list. We'll come to that shortly. Why is that important? Why would the problem be very different if it was a doubly linked list? Okay, so as I always say, whenever you want to solve a problem in coding, always try and see examples. Do it on paper, which will help you get your mind engaged in that. It will give you a lot of creative ideas and you will see a pattern in the solution. And once you see the pattern in the solution, you will be able to create a formula which is actually an algorithm. And the next step after that is pretty easy, which is to write down a pseudocode step by step of what needs to be done and then convert that into an actual code by putting the syntax of the programming language. Okay, so given linked list example, head is 4519, which looks something like this, and you are supposed to delete the node which has value 5. Okay, so basically what we want is this node, which is basically the second node, 5 should be deleted, right? And this is how it will look when you are given this and you are removing 5. You should get an output of 4, 1 and 9, right? So basically you have just removed it. It may seem really simple just by doing this, but when you jump onto a linked list and try to do it, the problem comes up. Okay, so you can try more examples. Maybe I can just show you more examples on this. So let's say this is another linked list. Okay, we can take more and more elements in this. Okay, let's just take 4 elements and let's see how we will delete, how we will work on this. Okay, so let's say the values are 1, 2, 3 and 4. Okay, and let me just show you the basically what is the signature of the function. Okay, the signature of the function looks like this: delete linked list list node. So basically you're giving the reference to the node which needs to be deleted. Okay, so let's say this is a linked list, right? And you are given the reference to, let's say, node number 2. Okay, so basically you are supposed to delete node number 2. Okay, thinking about it, it may seem easy to you and you will be able to write this as 1, 3 and 4, right? The solution seems very simple, that you simply deleted node number 2 and you will get this. But the problem is, to be able to delete this node, you will need the pointer to the previous node 1, so that you can assign 1.next equal to 3, right? You want this to be happening, otherwise you cannot delete it, right? Because till the time you're given access to node number 1, you cannot remove node number 2, because whenever you are at node number 1, whenever someone is traversing the list and they are at node number 1, whenever they do no 1.next, they will always reach 2, so there's no way to get rid of 2. In this way the question seems to be really tough. Okay, but the thing is, this is like a trick question. Okay, and I would like to point it out that this question will be asked in the interview, because it's actually very simple, and once you try to do it, the interviewer will try to change certain parameters in the question, so that they can gauge if you are able to think properly or not. It's a good warm-up question. Okay, so let me just show you how this can be done. Let's say we are back on the same list. Okay, we are at 1, 2, 3 and 4. Okay, and we are supposed to delete this node. So how will it look like when we have deleted it? It would look something like 1, 3 and 4. Okay, this is what we want at the end. Okay, now let me just give you a very good suggestion or advice. Always try to think logically about problem and try to find out what are the different possibilities, right? Like for example, in this case, we are sure that we cannot really delete the node number 2 until and unless we are given node number 1 also, right? So the node number 2 can never be deleted, right? It can never be deleted, because you don't have access to the previous one, right? So you cannot do that, right? So as soon as you get across this possibility and you understand that it's not possible to remove node number 2, you will begin to think creatively in other ways, right? For example, and now I'm coming to the solution. You cannot delete node 2, but you can do one thing, and that is you can change the value of node 2, right? You can cut the value 2 and change it, right? Now how will that be beneficial? It will be beneficial because by changing the value of node 2, you can copy the value of the next node over there and make it 3. Okay, so after this operation, this is what is going to happen. After you copy the third node's value into the second node, this is what will happen. Let me just draw the linked list with the values. So the first node will be 1, the second node will have the value 3, the third node will have the value 3, and the fourth node will have the value 3, right? So good that you have deleted the value 2, but the problem is the linked list has two values 3 values, though actually we were not supposed to have 3 values, right? So now the problem shifts. Earlier the problem was about deleting the second node. Now the problem becomes about deleting the third one, right? So again you can do a very similar kind of a thing, that is you can change the value of 3 and copy the next node's value over there. Okay, and when you do that, this is how your linked list will look like. 1, the next node will be 3, right? And the next node after that will again will actually be 4, and the final node would again be the same as the previous one, 4. Okay, and again this is not a perfect list because you have 2 times 4 coming, right? 4 is coming 2 times, right? But again the problem has shifted to the right, and what you all have to do is basically get rid of this second 4. And now this can be done very easily because there is nothing present over here, null is there, so you cannot really copy anything, but you can just simply remove the last node, right? If you simply remove the last node, you will get this 1, then we have 3 over here, and we have 4, right? And that's what we actually wanted. We wanted our linked list to look something like this, 1 3 4. And how do we achieve this thing? By actually copying node values from the next node iteratively till you reach the end of the loop, till you reach the end of the linked list. Okay, and this is how I actually did the problem the first time. Okay, but when I started thinking about making a video or helping people understand the solution for it, a very interesting thing happened. Okay, I came across in my mind even better solution to this. Right now the time complexity of the solution is order n. Okay, where n is number of nodes present in a linked list. So the solution that we have applied is order n. Okay, but there's a solution which exists which can be done in order one time. Okay, I will come to that in a short while. Let me just take another example and explain to you what exactly did we did. Okay, I'm just deleting this thing, and let me just show you how our solution is working, the present solution is working. So let's say we have 1, then we have 2, let's say we have 3, we have 4, we have 5, let's say we have 6, and let's say we have 7. Okay, let's say we have 7 nodes in the linked list, and let's say we are supposed to remove the node number 4, right? So our solution is that copy the value of 5 to 4, okay, then copy the value of 6 to the 5th one, copy the value of 7th to the 6th one, and then cut or remove the 7th node. Okay, let me just show you this in steps again. Basically we want the 4th node to be deleted, so what we are going to do is we will copy the 5th one over here. Okay, so this is what will happen. We will have 1 2, okay, let me just add it over here itself. Okay, so this value will become 5. We basically copied it over here, right? And in the next step we are going to copy 6 to 5, right? So this will become 6, and then because there are 2 6, we have to get rid of the second 6, so we are going to copy 7 over here. Okay, and when we have 2 7s over here, we can simply remove the last one, completely cut it by doing this 7 dot next, this 7 dot next equal to null, right? So eventually our linked list will look like 1 2 3 5 6 and 7. Okay, and why do I say the time complexity of this method is order n? It's because to get this method done completely, you have to traverse the list starting from the given node up till the last node, right? And this node this node can actually be the first node also, right? And if this is the first node, then you will have to traverse from here up to the last node, and hence it may take n iterations, and that's why the time complexity will become order n. Okay, I hope you understood this. Now let me give you the better solution of completing this in order one time, right? You may actually pause the video and think for yourself, can you do it in order one yourself? If not, you can always continue watching the video again ahead. Okay, so let's come let's draw the problem again. Okay, let's draw the linked list again. So initially we are given 7 nodes, right? We are given 1, we are given 2, we are given 3, 4, 5, 6 and 7. Okay, and the linked list and the node that we want to delete is node number 4, right? We cannot delete node 4 directly because we don't have the pointer to 3. If we had the pointer to 3, we could have just said 3.next is equal to null, but we don't have that pointer. We are actually presently present at node number 4, and we can only delete nodes after this, right? So the solution to this would be that we actually copy the first node over here from 5th, you will copy over here, right? You copy over here, so there will be 2 5s, right? So the problem has shifted to the right, but now there's a big difference. We can directly delete node number 5. Okay, let me explain to you how. Let me just draw this node again over here. Okay, after copying, let's say we have the linked list like this. One, 2, 3, 4, 5, 6 and 7. Okay, actually we had copied the value, right? So this is going to be 5, this is also going to be 5, this is going to be 6, and this is going to be 7, right? So this is our linked list, how our linked list is going to look like when we have copied this 5 to over here, right? And we are actually present at this node, right? Now because we are present at this node, we can delete this node, right? We can just point this to over here and we will be done. And what we have to do is this node 5.next is equal to 5.next.next if there is something. Okay, and we will be done. Okay, so as soon as we do that, this is how our linked list will look like. 1, this is how our linked list will look like. 2, 3, 5, 6 and 7. Okay, and we will get the answer. Why is it being done in order 1? Because we don't have to traverse the entire list. We don't have to traverse the entire list from here up to here. We are just copying one node's value, and then we are just applying the next pointer only 1 or 2 times, right? Which is basically countable as slow as 3 or 4, basically a fixed number, right? And that's why the complexity is constant. So the time complexity is going to be order 1. Okay, so let's just write down the solution, the pseudocode steps also. It's going to be pretty simple. If this is the if this is going to be the signature of the code, this is what we have to do. Okay, let me just show you. Basically node.well is equal to node.next.well, right? Which basically copies the code, copies the value from the next node, right? And then node dot next is going to be equal to node dot next dot next. As simple as that, right? And this will be done in order one. Let me just share with you the code also, how I actually did it previously. The order and function. So this is the code that I did. So basically the first thing that I did was, if node is not equal to null and node dot next is not equal to null, return, right? Basically if you have an empty list, you don't want to run into null pointer exception, right? So that's why in the case when node is null, you will just simply return and not do anything, right? And let's say if there's only one node, because a question says you don't would have ever have to remove the tail, you can simply return in even this case, because if there is only one node, when node dot next is equal to null, the head and tail are the same and you cannot delete anything, right? So that's why it's always better to consider the edge cases beforehand. And this is what I did. I ran a while loop, which is always true. This is not actually a very good way of doing a loop by running true, okay, but it gave me more logical power to ensure that what I'm doing is correct. Generally you should write a particular condition, okay? So let's see what I did. While true, what I did was node dot value is equal to node dot next dot well. Node dot value is equal to node dot next dot well, right? So basically copying the next node's value into the present node, and then I run this, which says if node dot next is equal to null, node dot next is equal to null, and return, right? Basically if you are towards the end of the list already, you simply break it. Otherwise what you have to do is keep iterating, that is move to the next node, right? Like what I was showing you over here, that keep copying. I showed you earlier that we were just copying the node till we reach the end. This is what this loop is doing, okay? If you ignore this if statement, if you just ignore this if bracket, what this is doing is node dot value is equal to node dot next dot value, basically copying from the value right node to the present node, and then changing the current node to the next node till the time you reach to the end. And for that I have written this if thing, okay? Now just to check, I have not written the code which works on order one, okay? I just came across this idea while I was making the video, and this is very important thing which I would like to put it to you. If you really want to learn something, right, really master it, the best way to do it is to teach. Find a friend who would be interested and teach that question to them, okay? Discuss with them, even try to explain the problem to a layman. Of course they won't be able to understand the computer science concepts, but try to simplify it so well that even someone who doesn't understand computer science can understand it, right? uh, I learned this kind of technique while reading about Feynman, okay? He and or maybe Einstein, I don't remember, but they talked about making the problem so simple that even a kid can understand, right? And when you try to do that, your brain develops and you get a lot of solutions. And that's what happened practically with me in this. Earlier when I had this problem, I just tried to do it the way I like, and that's why I came with order and solution. And the site also was able to pass my solution without any problem, because it was not really expecting a brilliant order one solution, right? But when I thought about creating this video, I was thinking and I got this answer which works in order one, right? So let's just do that. Okay, if basically node is equal to null and node dot next is equal to null, we are going to return, right? Otherwise what we are going to do is node dot value is equal to node dot next dot well, okay? So basically copied next value, okay? And there would at least be two nodes, right? This won't ever run into a null pointer exception, because I've already taken care the condition that either if there are zero nodes or there is only one node, we will return already, right? So by the time it comes to the second line, there will always be two nodes, so there will be no null pointer exception over here, right? So I copied this value, and then what I'm going to do is I'm going to say node.next, which is basically now the second node from which I copied the value be deleted, and this can be done by doing node.next. Okay, so I didn't run this function before. Let's just hope everything is working fine, and let's see. Let me just run the code and see if it is working on the test case. Good, it's working on the test case. Let me just submit and see if it actually gets submitted um, with all the test cases that web. Good. So as you can see, my runtime is 0 milliseconds and it runs 100% faster than all the submissions for this, right? So probably not many people thought about the solution either. Okay, but just because I had been practicing this for a while, and I thought about making it for making a video for you guys to understand, I was able to do that, right? So let me just undo and show you that even the previous code was working fine. As you can see, even the previous code was working fine, right? So this is how you do questions in data structures algorithm. This is the end of video number 4. Okay, you are welcome to join the group. The link will be there somewhere, which is learnwithakshay.com DSA daily. Please join the group till the time it's free. Soon there will be a lot of members which will be joining the group, and if there are a lot of people and it becomes hard for me to manage, I might make the membership paid. Okay, so bye bye, take care, happy learning. And also don't forget to subscribe the channel. I always forget that. Please subscribe the channel and like the video, and drop me in the comments below if you have any kinds of doubts. Okay, bye bye, take care.